Hello everybody and welcome to today's Petrus's webinar in which we're going to look at the new connector to ELIS Next Generation Interpretation Package PaleoScan. My name is Ewan Rule. I'm a sales geoscientist with Petrus's based in the UK office, and I'm joined today by Jean-Philippe Adam, who's the Global Portfolio Manager for ELIS. Please note that this webinar will be recorded and it will probably last around about 30 minutes. So for our agenda today, we're going to start off with a brief introduction to PaleoScan. Jean-Philippe has kindly agreed to give us a 5-minute overview of the software itself so you can see how what the advantages are of using this excellent software. And we'll then have a very short PowerPoint within Petrus's when we'll look at what you can do in Petrus's Pro 2019.3.1 and how you can use the PaleoScan connection when you're working with our mapping, our surface modelling and our 3D viewer. We'll then have a live demo and we'll close off by looking at our future plans for the connection and how we're going to develop it. So I'm just going to hand you over to Jean-Philippe for the introduction to PaleoScan itself.
Hi, hello everybody. I'm Jean-Philippe Adam. I'm Global Portfolio Manager for ELIS, and I will present you briefly PaleoScan interface and why PaleoScan is unique, and the basic workflow of PaleoScan. First of all, I will start with the presentation of PaleoScan. It's interpretation software for 2D and 3D seismic. And first of all, just short presentation of the dataset we will use. We will use this dataset. It's FR3 dataset. It's North Sea volume, north of Netherlands. And first of all, we try to have a software user-friendly with a lot of things done on the fly. Just an example, it's the color bar. I can just change the color bar. Everything is done on the fly. We have one tool. Okay, we use a lot. I will just change this frame. It's crossline. It's what we call the cross navigation, and then I just drag the mouse, and all the viewer will be focused exactly on the same point. And okay, it's just for presentation of the platform. Now, why PaleoScan is unique and we do interpretation. In fact, PaleoScan has a new unique object for the workflow. It's what we call the model grid. The model grid, took just a few seconds. Model grid, it's this kind of object. In fact, if I just play with the parameter just to show you my model grid. Okay, in fact, the model grid, it's all the yellow dots you can see on my screen. To create all these yellow dots, it's based on the seismic amplitude. We use peak, trough, zero crossing. We can use inflection point also, for example. And then we have a spatial resolution. Like this, we create all these nodes through the full volume. Okay, as you can see when I navigate, it's not only on one frame, but all these dots are created on the full volume. And then we create a small horizon for each yellow dots, and then we try to connect all these nodes all together to have an automatic solution. It's all the black line you can see on the screen. And like this, I will just zoom out. Automatically, I have automatic solution. All these horizons are created automatically through the full volume. But then, okay, even if it's good software and we try to have better and better automatic propagation, it's not magic, and we still need people to control and check this automatic solution. For example, I will just start one horizon. For example, this one, you see this one on the faulted area due to the faulted stop. On this one, it's where I need to, say I want to connect this one, with this one, and complete my horizons, due to different kind of thing with the seismic, volcanic intrusion, low signal to noise ratio, extra, multiple, etc. You need to have a lot of tools to refine and change this automatic solution. For example, you can erase, you can also erase from the map view, you can undo, you can redo, you can do many kind of things, and then if you want, just to show you, you have the full control like this. Okay, you can really change this automatic solution. And then, okay, I will just close my viewer. I will open a final interpretation based on yes, this one, based on this automatic solution and your refinement. Okay, just a few seconds to show you a final interpretation. We spend a few weeks, 2 weeks on this interpretation. We connect more horizons all together. We create the next step of our workflow is what we call the relative geological time model. Okay, if I drag and drop my seismic and I drag and drop my model, it's just to show you, okay, we obtain this kind of thing where each color, each value, it's relative geological time. In fact, we have more something like this. We have interpolate between the node, and if I just isolate one value, I'll just zoom out. This volume, it's a full volume of horizons where each value is relative geological time following your interpretation and the automatic interpretation. And using this volume, we can create the last step of our basic workflow. It's what we call horizon stack. Okay, I just choose my model as input and choose my seismic. I will choose, using this model, one upper limit, one lower limit, and then the number of horizons between I want to extract. Okay, it can be 5, 50, 500, as many as I want because my model is continuous. And then I can map any kind of attribute on it, and we will obtain this kind of object. Okay, I will just open the seismic to have the intersection and one horizon stack. We obtain this kind of object. The name of this object is an horizon stack, and this horizon stack allow you to scan the volume not in time slice, but horizon slice following your geological event, because we use your interpretation. And like this, it allows you to very quickly scan the volume and detect some events. For example, if I go, we have very nice polygonal fault, very nice image of polygonal fault on this one. If I go on the upper part, we have very nice bright spots where, just on this part, we can extract that geobody. We can do many kind of things using PaleoScan. This is the basic workflow of PaleoScan, and then if you want, you can export your horizon to other software, for example, Petrosys. Okay, I will just change the presenter. Thank you for your attention.
Thank you very much, Jean-Philippe. That was really useful, and we'll continue with how Petrosys can complement PaleoScan. So, to use the Petrosys Pro 2019.3.1 PaleoScan connector, you need to have the current release version of Petrosys. You also need to have PaleoScan 2019.1 or later. The initial release of the connector supports PaleoScan Horizons, which in Petrosys we treat as grids. And the last thing that you'll need is the PaleoScan PS Data I/O key. So hopefully you'll have access to that. If you have any problems connecting up to the license, then please get in touch with Ellis or ourselves and we'll see if we can get you going with it to test the link. There are three main areas of functionality that Petrosys adds. The first one is the mapping, which is what Petrosys Pro is best known for. And from PaleoScan, we can display both what we're calling the Z-value and the data horizons within Petrosys. So these are the structures and any associated attributes. You've got the full Petrosys grid display options. So you can display sun-shaded, color fill, you can display the grid values and also the highs and lows. And importantly, you can integrate the PaleoScan horizons with other data that might be available to you, like data in other interpretation systems or GIS. And most importantly, we're offering advanced presentation quality mapping, and it's really easy to get good outputs to things like PowerPoint, PDF, and raster images. You can also use your PaleoScan horizons in Petrosys surface modeling. So I'm sure PaleoScan does a really good job of generating the horizons themselves, but one of the advantages you might find is being able to combine that data with other interpreted data coming from other sources. We can also import the PaleoScan horizons to Petrosys' own grid format, And that allows us to utilise additional features such as our grid editor, our volumetrics. We do both deterministic and stochastic volumes. We can automatically generate Lewis closing contours, and there are a whole range of other functions within our surface modelling which you may find useful. And we can also do what we call exchange, which is using Petrasys as middleware to move the data between other applications. So we can move data from PaleoScan into certain other interpretation systems. And finally, we have a 3D viewer. As you would expect, we can also display the horizons in here, and we can drape the attributes on top of the structures. And this also allows us to combine the PaleoScan data with any other data that you have coming from other sources. Now, while you watch this demo, I'd like you to think about other data types from PaleoScan that you'd find most useful to map in Petrasys. This is just the start of our integration with PaleoScan, and we're looking for guidance from our clients in what their priorities are. So we'll just move into the live software demo now. For anyone not familiar with Petrasys, this is what our main panel looks like. As with Jean-Philippe's demonstration, we're going to use the F3 dataset in the northern Netherlands sector of the North Sea. And we'll start off by going into the mapping window. So bear with me if a few of the windows take a few seconds today. I'm just working off a laptop and I've got quite a lot of different applications running, so it seems to be a little bit on the slow side, but I'm sure it'll work okay. So this is just a fairly basic map window we have here. We've got coordinates on the inside, we've got a scale bar. To start getting the data into the software, you can use the icons once you're familiar with them. From some applications, you can drag and drop. To get the PaleoScan data in and go to display, choose grid, and then we'll just start off choosing colour fill. So we'll see we've got a range of different data sources available to us, and we'll choose PaleoScan and then connect up to the F3 project. So to do this, we just need to identify the location of the PaleoScan project directory. And on my laptop, that is just in program data. So we just pick up the top level directory, and then the software will just check and see if you've got a PS Data IO license, and that gives us a connection. So we can now select which horizon we want. I'm just going to start off selecting the channel ISA core down here. Just take the Z value. And you can see you've got quite a lot of options already to control how this data is displayed. You can choose if you want to invert it, if you want to exaggerate. There are a whole range of different colour gradients. And you can also make it translucent, but let's just put on this first horizon. And you can see here that we've got this, what we call a dynamic extent, so dynamic area of interest. It just sizes to whatever data is currently displayed. And when I hold down my mouse button over here, we can pan across the grid or the contours, and down in the bottom here you can see that it's coming from PaleoScan in both the coordinates and also the values of the grid itself. Now this is a live grid coming from PaleoScan. When we display it at first, it becomes cached, which means we take a local copy just so it displays more quickly. At any time, if you update the data within PaleoScan, then you can update it in your Petrasys map too. And we have these options in the toolbar just to update the cached data and requery the original database. So to move things on a little bit quicker, I'm going to merge in some other data here. And I've got a Petrasys DBM file, which is just a list of data that we want to display. And we'll merge that in with the existing dataset. It's actually also still from the F3 project. So the channel is now obscured by the surface up above it. If we want to see it, we can just drag it up to the top of our display list and it'll appear on top of the other data. We'll just switch it off though, and we'll have a look at what else we've got displayed and how you can display these PaleoScan horizons within Petrasys. So down at the bottom here, we've got the actual structure grid. And this particular one is just for one of these horizons that's been created with the Butterworth bandpass filter. So you can use different colours in here for displaying structure grids and attribute grids at the same time in mapping. I quite like to use the monochrome sun-shaded option. It gives you a really good display of the surface itself, and also putting the contours on top helps you understand the interpretation of the structure. Now we can also put on the associated attribute grids. Just choose the data type grid from the link, choose your color bar, and then the nice thing to do here is to make your attribute grid translucent so you can see through to the structure grid underneath. So we'll just switch that back on again. And you can see here we've got the structure. We've got this north-south pattern here. Don't know whether these are faults. And in just a second, the attribute will display again. You can see in some places the attribute does relate to the structure, in other parts there's a bit more of a variation. So this all helps you as an interpreter work out what's going on, and also gives you these nice presentation quality outputs. Now there's a lot we can do in Petrasys to improve the appearance of the map. Just as an example, we'll have a look at the contours that we have displayed here. So when we open up the contour layer, we can see that we've got an increment of 25. Every 100, we've decided to display the line a little bit thicker, and we'll just increase that again. You can also put on labels. It's always good to label your data if you know what the domain is, just to make it really clear to people that are looking at it. So we'll just put on some contour labels here. And another nice feature in Petrasys is that any text that's displayed in your map can be moved or hidden, so that all the key pieces of text in your map, like well locations, will always be visible. We'll just show you how to do that with the contour labels though. When we select them, we've got this option which we call Overpost Correction. And if I don't want to have a contour label here in this bend, we can just move it around a little bit to somewhere where it's a bit more easy to see. Also, if we wanted to add in some additional contours, there's quite a nice option here that just lets us draw a line in the map. And then all of those contours that were bisected by that line will now get a contour value as well. I'm not going to keep the contour values, so that was just as a reminder of the overpost correction functionality. So we'll zoom back out to our data extent. We'll switch on the attribute again. And we'll start to add some other data onto this map. So I'm going to pick up another grid, but this time I'm going to pick it up from a different interpretation system. Petrasys also has a plugin for Petrel, which I've started it from today. So if I go to Petrel, I can also connect up to the project that I've begun with, and I have an F3 project in here too, so I'll just take this FS4 surface. I don't think we'll bother contouring this one, we'll just put the colour fill on. And as I mentioned, there's a whole range of different colour gradients available in Petrasys, and in fact we'll be shipping some more in the next release. But we can also import them from a lot of different applications, including Petrel itself. I'm not sure how appropriate this one is, but we'll just pick one of the Petrel gradients and we'll put this onto the map too. So while we're in the dynamic mode for the extent, each time new data is added, it just resizes the area of interest. And we'll see this horizon from Petrel. We'll just overlay the other stuff that's happened before when we added this data on above the channel. But of course we can reorder these things, or we could make the other horizons translucent if we wanted to see through them. Okay, so there we've got the horizon coming in from Petrel. Our main focus was the PaleoScan data, so we'll just move it down to the bottom. Now you can see from the display list there are a lot of different data types that Petrasys works with. So you've got things like bubble maps, you can display data directly from Excel. GIS data we'll talk about later, but we're just going to add in some well data from Petrel too. As I said, we're looking for feedback on what other data types we should be adding in from PaleoScan. So please put a note in the chat log if you think that wells is one of your key priorities here. The sorts of things that we can display from Petrus is our top and bottom hole locations. We try and match up the well symbols too with the application that we're connecting up with. Then of course you can do annotation, you can display deviation surveys, tops, thicknesses, and you can also do log signature maps. But I'm just going to put on these well locations, so we've got some well data posted on here too. We've made the labels opaque so we can see them clearly above the different grids that are displayed. So quite quickly we've built a map with two different interpretation systems. If I was ready to put this into a PowerPoint, I just need to click on this one button here. And in my PowerPoint demo, you can see that we've automatically got an image from the map. It's been sized correctly to the size of my PowerPoint slide, and it's pretty good resolution, so it's really easy to get your maps into PowerPoints, which of course are what many people use when they're presenting to partners and management. Now going back into Petrus's, I think we're just going to expand the area of interest. So we'll go to our display again and we'll choose a different grid to display. This time we're going to go to PaleoScan a second time. And instead of the F3 project, we're going to add in data from a second PaleoScan project. So this one is from the Dutch sector as well. It's from block K5, which is a little bit to the southwest of F3. But the point is you can connect up to as many different PaleoScan projects as you want. I think you need one PS Data IO license for each project, but you can add multiple projects at the same time. We'll just go back to the turbo gradient that we used for the initial PaleoScan data. Just pick this one up here. And we'll put this one onto the map too. It helps if I select a grid and not just a project itself. We'll go with this Topps-Eckstein Z-value grid. So you can see the area of interest has got much larger, and we've got this other project down in the bottom left-hand corner. Now we could also add in other data types, so I mentioned that we have the option to display data from GIS. You can display directly from shapefiles. Again, you're not importing anything into Petrus's formats, you're just taking the live shapefiles. Things like Esri file geodatabases too. I've got a file geodatabase here, and it's actually got some top information for the Topps-Eckstein. So let's just put that onto the map. We'll just choose a gradient here, and we'll use the Z-value as the attribute that will control the color gradient. So we'll just see some circles appear here showing the top depth for the Topps-Eckstein across this area. So we've now got data coming from GIS. We've got two different PaleoScan projects and also Petrel. If we want to make this a fixed area of interest, we can do that at any point just by doing a right click and saving the extent. And once you've saved those extents, you can pick them up from this menu here. So we'll just choose this extent called Netherlands Offshore North. Essentially, it's just the same area as we've currently got displayed. Some sites will also create what we call base maps. So we have a base map here, which is for the Netherlands. It's with data from the Netherlands oil and gas. And essentially, it's a whole lot of cultural information that's available publicly. So things like field outlines, the well locations, license blocks, all of that sort of stuff. So these are all coming directly from GIS data sources too, also raster imagery. And as you can see in Petrus's, you can have folders of data so you can switch things on and off easily. Now, if you set this data up and it stays in the same location, if it gets updated periodically like license blocks and field outlines do, it'll automatically update in your map as well. So in not very long, we've built up really quite a nice looking map with data coming from a whole lot of different data sources. We set this one up to work with PowerPoint really, where we're maximizing our screen real estate by having the coordinates on the inside. But you can also set up different corporate styles. So if I was going to produce a map that I wanted to see in a poster presentation, I may choose a different style. It will keep all the data the same, but it will just give you different information round about the map itself will appear in a slightly different way. So now we've got both XY coordinates and also latitudes and longitudes. We've got a company title block. Our scale bar is a bit more prominent. Sorry, where did that go? We've got a north arrow, and we've also got a location map here. We could zoom in on this if we want to, but this is really quite a nice looking map now. So another very useful option for sharing your maps with people is to write this out as a PDF. So we'll just create a PDF. It will take a few seconds for it to write. The PDF will be both geospatially aware, so it will actually have real-world coordinate information in it, and it will also maintain the layers that you had displayed in your Petrus's map at the time you did the export. It's just taking a few seconds to calculate a location map. Everything's just a little bit slower in the laptop today. So there we go, we've got a nice PDF vector format. The resolution in here is extremely good. And as I mentioned, you have all the layering down the side here. This is just free standard Adobe, nothing you have to pay for here. If you're not interested in the cultural information, you can just switch off the base map. And then you can look at the different things that you have displayed from the geoscience systems as well. Just switching things on and off so that you can discuss them with your colleagues in peer reviews, can discuss it with partners, or you can present it to managers. And you don't need any of the specialist licenses from the interpretation systems, from the GIS, or even from Pegasus itself, just the PDF. So the next part of the demo, we're going to move into the surface modelling and see how we can use the PaleoScan data there. Within Petrus's surface modelling, you can do all sorts of different functions and tasks. You can also build up what we call workflows if there are certain processes that you want to repeat regularly. So I've just saved a little workflow here just to look at some of the functions that we can do already with the data coming from PaleoScan. So the first option is just to create a grid in Petrus's, and we've got a lot of different algorithms and methods in here. We won't necessarily run this gridding itself, but just to show you the sort of thing that you can do. When you're looking for your input data, you've got access to all the same sources that we had in the map. So essentially anything with coordinates and z-values you can use as an input for gridding. So I could choose to take this file geodatabase from Esri with the top Zechstein Z value, but we know we've also got a top Zechstein horizon from our K5 project in PaleoScan. So to add that in, you can either use the icons when you're familiar with them or just use the Add Data Source button. We'll switch over from spatial to grids, and we'll connect up again with PaleoScan K5. And once we have that connection, we can choose the grid that we want. So that would be the top Zechstein Z value, and we could add that into the display list and use both those data sources to create the grid. So it would give us high quality 3D resolution top Zechstein where we had the PaleoScan data, and it would interpolate out over those top depths from the shapefile elsewhere. The second option I want to show you here is the one that allows us to export the PaleoScan data to import the PaleoScan data to Petrus's. So far, everything that we've seen in the map has been coming directly from other data sources, from PaleoScan, from Petrel, from GIS. Nothing's been imported. But in this case, I'm going to import from PaleoScan into Petrus's grid format. So you can do some filtering here if you're not interested in the z-value grids and you just want the data grids. You can just click those on. And there's a whole lot of reasons why you might want to import into the Petrasys format. As I say, we have a spatial editor that allows us to do things like editing grids. If you edit a small part of the grid, then you can do localized regridding and leave the rest of your data as it is. And I'm just going to open up ArcMap for a second. While ArcMap is opening, we'll go to the Petrasys project directory and find the location where we wrote those Petrasys grid files. So we just put them into this folder here. So I'm hoping this is going to work. I have had a problem running all this software at the same time in my laptop, but we'll just give it a few seconds and see if ArcMap pops up. Okay, so we've now got Arc started, and we should be able just to pick up these Petrasys grids and drag and drop them into ArcMap. We also have a plugin for Esri that allows us to display things like Petrasys grids, contours and faults as native features within ArcMap. So now you can see them all appearing. It's almost similar to what Jean-Philippe was showing in the PaleoScan data. You can see those different attribute grids appearing one on top of another. And if you have colleagues working in the Esri environment, they can continue to work with that data, set the color gradients and all those sorts of things that they might like to do. The last thing we'll do in the surface modelling part of the demo is we'll use the exchange option. And this time we're going to take the PaleoScan horizons and we'll write them straight into Petrel. We're going to use the z-value, the structure horizons here. We've chosen our Petrel project. We can also write into things like decision space, Dug Insight, or Paradigm from here. And you might find that you need to invert the grids depending on the different depth domains. And we're just going to create a new folder within Petrel called Petrasys Grids. So this will take a few seconds just to prepare this data before we push it into Petrel itself. I'm aware that PaleoScan has a Petrel connection, but it can be quite useful to have more than one way of moving data between the different applications. Right, so let's go into Petrel, into the F3 project. And down at the bottom of the input data, you can now see that we've got a folder called Petrasys Grids. So they should be displayed now in the 3D window within Petrel, and there you can see we've got those horizons written in from PaleoScan. I'll just switch some of them off so you can see that they're all actually there. Now the last thing we're going to look at in the live demo is the Petrasys 3D viewer. And once again, just to save us a few seconds, I'm going to open an existing 3D file. So what we're doing here is we've got connections to both the PaleoScan project and the Petrel project. We're just requerying those databases and displaying the data directly out of there. So as you can see, we're starting off with the PaleoScan structure grid and with the attribute draped on top of it. But we've also got the connection to Petrel, and we've also got this idea of having folders. So if I just switch on the Petrel folder in here, we've now got that F3 horizon displayed and also my wells with the tops from Petrel. So potentially, if we add support for wells in future from PaleoScan, you could use this functionality to QC your well locations and your top values between the two different applications. As with the mapping window, you can also connect up to multiple Paleoscan projects. So just to bring it home again, we'll go to our K5 project and we'll display that grid in the 3D view. This is the process you would do if you were connecting up yourself. So we'll choose our top, Zechstein. We'll just accept Petrus's default here. It doesn't really matter too much what the color gradient is for the demo. And we're going to invert just to keep it in the same orientation as the other data we've currently got displayed. So after a few seconds, we've got that other grid displayed away down to the southwest as we saw in the mapping window. You can also display point data in here, so we can also add in the geodatabase from Esri. We can add in the z-value that we displayed. So the 3D viewer can be really useful for a bit of QC before you actually move on to things like surface modelling, just to see how your data relates to each other. And let's just switch that on so we can see those data points. Again, with that colour gradient, you can see the top Zechstein wells that we've got from the GIST data round about the Paleoscan horizon. And the final thing I'm going to switch on in here, we can display raster images into the 3D viewer either draped on a surface or else on a plane. We can do the same thing with the Petrus's DBM files. So I'm just going to display the cultural information that we had from Netherlands Oil and Gas, the field outlines and the license blocks, and we can just display that on the surface essentially at sea level. So the 3D viewer is quite a nice tool to use for combining the data from Paleoscan with other applications in Data 2.